Iranian American, I'm inspired by the legacy of ancient Persian mathematicians and scientists. Science is a timeless, borderless adventure. I am honored to receive this prize for work I have done with over 150 first-rate physicists and mathematicians from all over the world. I'm greatly indebted to them and also to my parents, my 3 sons, and my wonderful wife and best friend Afarin for the inspiration and joy they have brought to my life. Thank you.
با سلام و درود، محمد هستم. به عنوان معلم فیزیک و محقق توی رشته فلسفه قرار اطلاعات خودم رو توی زمینه‌های مختلف به اشتراک با شما بذارم. یکی از افرادی که با من در تعامل بود یه سوالی از من پرسید در مورد این که آقای محسنی، من فرمول هایی که میبینم، مثلا فرمول انرژی جنبشی 1/2 ویدیو، 1/2 KX2، 1/2 LI2 توی خازن‌ها، القاگرها، 1/2 CV2 توی خازن‌ها، اینا چرا فرمول ها داره اینقدر یکسان پیش میره؟ گفتم این برای خود من هم خیلی جالب بود که سوال بود چرا وقتی من دارم تدریس میکنم همه فرمول ها این مضرب 1/2 x y به توان 2 رو داره یدک میکشه، چرا اینجوری هن؟ بعد برای من جالب بود این که حتی پرسیده شد چرا ما گاهی وقتا میگیم که قانون مثلا نیوتن قانون جاذبه، ولی بعضی وقتا میگیم اصل مثلا پاسکال. این فرق بین اصل و قانون چیه؟ وقتی که یه کمی کنکاش کردم برای خودم هم خیلی از مطالب باز شد و خیلی هیجان انگیز بود برام که این مطالب رو دوست دارم با شما هم به اشتراک بذارم. بچه‌ها، قانون در مورد یک فکت علمی، یه پدیده‌ای که چه شما بخواید چه نخواید داره صحبت میکنه. یعنی چی؟ مثلا میگم این موس رو من ول بکنم، این میاد پایین. خب یعنی یه واقعی، یه فکتی، یه پدیده‌ای که چه شما بخواید چه نخواید داره اتفاق میفته. به این میگن قانون. قانون یک اتفاقیه که به بیننده، به کسی که در موردش داره مثلا فکر میکنه اصلا ارتباطی نداره. شما چه بخواید چه نخواید این اتفاق میفته. به این میگیم قانون جاذبه. ولی اینکه این چگونه میفته یادتون باشه بحث چرایی هم در علم وجود نداره. ما نمیگیم چرا افتاد، ما بدونیم کار خداست، نمیدونیم قوانین اینجوری ان اونجوری که آقای هاکینگ داره میگه. ولی اینکه چگونه داره میفته مدل سازی بکنید که این توضیح بدی این افتادن رو، این میشه نظریه. این حرف هایی که توی کتاب ها نوشته میشه که ما نظریه میسازیم، اگر نظریات اثبات بشن میشن قانون و اصل، اصلا این چیزا درست نیست. اینا رو بذارید کنار. قانون پدیده‌ایه که داره رخ میده و نظریه چیه؟ نظریه اون بحثیه که شما میگید اون چگونگی مدل سازی شما رو داره توضیح میده که مثلا چگونه داره میفته رو بهش میگن نظریه. حالا میتونه نظریه نیوتن باشه در مورد افتادن این اجسام یا نظریه نسبیت انیشتین باشه. هیچ وقت ما توی علم نخواهیم گفت قانون نسبیت انیشتین، همیشه خواهیم گفت نظریه نسبیت انیشتین، چون در مورد افتادن این اجسام داره توضیح میده. این توضیح رو بهش میگن نظریه. هیچ وقت نظریات یا قوانین اثبات نمیشن. ما کلمه اثبات رو توی علم، توی ریاضیات فقط به کار میبریم. توی قوانین فیزیک ما کلمه‌ای به نام تایید داریم، وریفای میکنیم. خب پس نظریه اینه که این داره میفته به این دلیل. حالا توی مرکز هسته زمین چیزیه، چیزای نظریاتی که بود، یا آقای نسبیت انیشتین میگه که یا نظریه نسبیت انیشتین میگه که ما یک فضا زمانی داریم، اسپیس تایمی داریم که کروچری انحنایی ایجاد میکنه به دلیل جرمی که اون کره زمین داره و این باعث میشه که این انحنای باعث میشه این جسم دور بچرخه. مثل این فرض کنید ما یه صفحه داشته باشیم که یه سنگ روش بذاریم، انحنای ایجاد میکنه، یه چاله درست میکنه که وقتی یه تیره دیگه، یه سنگ دیگه بغلش بذاریم دور میچرخه تا تو این چاله بیفته. حالا این موس مثلا داره دور میچرخه تا توی این مثلا چاله بیفته، ولی چرا ما میبینیم صاف میاد؟ به این دلیل که این ما اون انحنا یا تاب زمان یا تایم وارپ زمان رو ما نمیبینیم، فقط چون دید ما سه‌بعدیه، ما سه‌بعدیشو داریم مشاهده میکنیم و اون بحث کروچر رو مشاهده نخواهیم کرد، ولی در واقع این داره توی زمان تاب میخوره تا به روی زمین بیفته. این میشه قانون، این میشه نظریه‌ای که برای افتادن یک جسم برای افتادن یک جسم ارائه میشه. به این میگیم نظریه. ولی اصل چیه؟ اصل میشه گفت که همون قانونه، ولی یه محدوده‌ای داره، لوکال، موضعیه. یعنی شما میگی اصل پاسکال. اصل پاسکال فقط برای شاره‌ها، مایع‌ها و گازها صادقه و اون هم گازها و مایع‌هایی که محصور هستن، یعنی یه جایی بسته شدن، یعنی توی یک محدوده بسته و ساکن قرار دارن. اینه بهش میگیم اصل پاسکال. یعنی برای شاره‌ها یا مثلا گازهای مایع‌هایی که در حال حرکتن صادق نیست. مثل اصل برنولی، ما هیچ وقت نمیگیم قانون برنولی، میگیم اصل برنولی. اصل برنولی چیه؟ اینه که سرعت و فشار رابطه عکس دارن. تو دوره دبیرستان خوندیم این که دو تا کاغذ رو وقتی من کنار هم دیگه قرار بدم، وقتی بینشو فوت میکنم کاغذها به جای که از هم دور بشه هم نزدیک میشه. یعنی سرعت که داره زیاد میشه، فشار کم میشه، فشار هوا در اطراف بهش وارد میشه و کاغذها رو به هم نزدیک میکنه. به همین دلیل که این رابطه بین فشار و سرعت یک رابطه معکوسه، ولیش اینجاست که این پدیده فقط برای سرعت‌های کمتر از سرعت صوت، یعنی 340 متر بر ثانیه صادقه. بالاتر از 340 متر بر ثانیه قانون اصل برنولی صادق نیست. به همین دلیل ما میگیم اصل برنولی، چون یه محدوده داره و برای این قسمت از قسمت فیزیکی ما صادقه. برای محدوده‌های دیگه بالاتر از سرعت صوت صادق نیستش. به همین دلیل باید ما محدوده قانون و اصل رو از هم مجزا بدونیم. پس میشه گفت که اصل زیر مجموعه قانون خواهد بود به این معنا و نظریه هیچ وقت اثبات نمیشه. شما مثلا نمیگیم نظریه نسبیت انیشتین اثبات شد، چون اثبات گفتم توی محدوده ریاضیاته و ریاضیات طبق تعریف‌هایی که توی یکی از سرفصل‌هایی که قرار ارائه بدم در مورد علم و شبه علم، اینکه ساینس چیه و فرقش بین با نالج و علم به اون معنایی که توی ذهن ما ایرانی‌ها هست چیه بازتر خواهد شد، ولی حداقل این محدوده رو باید کنار گذاشت. اون سوال اول رو هم من توضیح بدم که چرا فرمول‌ها اینجوریه. واقعا باید بگیم نمی‌دونیم، ولی یک فیلمی هست از آقای موری گلمن به عنوان یکی از فیزیکدان‌های برتری که تو این زمینه کار کرده و برنده جایزه نوبل هم بوده. توی یوتیوب و آپارات میتونید این فیلم رو پیدا بکنید. داره توضیح میده که ایشون هم به این سوال برخورده و سوال خیلی از فیزیکدان‌ها و ساینتیست‌ها تو این زمینه هم هست و ایشون چون توی نظریات ذرات بنیادی کار میکنه اعلام میکنه که توی اونجا میتونید با جزئیات بیشتری اونجا مشاهدهش بکنید. این که ما نیروهایی که توی طبیعت داریم، نیروهای گرانشی، الکترومغناطیسی، نیروی هسته‌ای ضعیف و نیروی هسته‌ای قوی. جالب اینجاست که ایشون و همکاراشون، حالا آقای جولیان شورینگر بوده، آقای واینبرگ بوده و افرادی که توی این زمینه بودن، تونستن 3 تا نیروهای الکترومغناطیسی، هسته‌ای ضعیف و هسته‌ای قوی رو به هم اتحاد بدن و بگن اینها یک منشأ دارن و جایی برن که نظریه بیگ بنگ شروع میشه. توی اونجا شما میتونید این 3 تا نظریه رو، 3 تا نیروی بزرگ رو همزمان با هم ببینید. حالا به اون دلیل اون انفجار بزرگ، اون بیگ بنگ، اتفاق بزرگ، این 3 تا نیرو از هم مجزا شده و اون تفاوت‌هایی که شما الان میبینید بین هسته‌ای ضعیف، هسته‌ای قوی و نیروی الکترومغناطیسی از همونجا انشعابش پیدا شده.
Thank you for putting up these pictures of my colleagues over here. We'll be talking about them. Now I'm going to try an experiment. I don't do experiments normally. I'm a theorist, but I'm going to see what happens if I press this button. Sure enough. Okay. I used to work in this field of elementary particles. What happens to matter if you chop it up very fine? What is it made of? And the laws of these particles are valid throughout the universe, and they're very much connected with the history of the universe. So we know a lot about four forces. There must be a lot more, but those are at very, very small distances, and we haven't really interacted with them very much yet. The main thing I want to talk about is this, that we have this remarkable experience in this field of fundamental physics that beauty is a very successful criterion for choosing the right theory. And why on earth could that be so? Well, here's an example from my own experience. It's fairly dramatic, actually, to have this happen. 3 or 4 of us in 1957 put forward a partially complete theory of one of these forces, this weak force. And it was in disagreement with seven, count them, 7 experiments. Experiments were all wrong. And we published before knowing that, because we figured it was so beautiful, it's got to be right. And the experiments had to be wrong, and they were. Now, our friend over there, Albert Einstein, used to pay very little attention when people said, you know, there's a man with an experiment that seems to disagree with special relativity, D.C. Miller. What about that? And he would say, oh, that'll go away. Now, why does stuff like that work? That's the question. Now, yeah, what do we mean by beautiful? That's one thing. I'll try to make that clear, or partially clear. Why should it work? And is this something to do with human beings? I'll let you in on the answer to the last one that I offer, and that is, it has nothing to do with human beings. Somewhere in some other planet, orbiting some very distant star, maybe another galaxy, there could well be entities that are at least as intelligent as we are, and are interested in science. It's not impossible. I think there probably are lots. Very likely none is close enough to interact with us, but they could be out there very easily. And suppose they have, you know, very different sensory apparatus and so on. They have 7 tentacles, and they have 14 little funny-looking compound eyes, and a brain shaped like a pretzel. Would they really have different laws? There are lots of people who believe that, and I think it is utter baloney. I think there are laws out there, and we, of course, don't understand them at any given time very well, but we try, and we try to get closer and closer. And someday we may actually figure out the fundamental unified theory of the particles and forces, what I call the fundamental law. We may not even be terribly far from it. But even if we don't run across it in our lifetimes, we can still think there is one out there, and we're just trying to get closer and closer to it. I think that's the main point to be made. We express these things mathematically, and when the mathematics is very simple, when in terms of some mathematical notation you can write the theory in a very brief space without a lot of complication, that's essentially what we mean by beauty or elegance. Here's what I was saying about the laws. They're really there. Newton certainly believed that. And he said here, it is the business of natural philosophy to find out those laws. The basic law, let's say, here's an assumption. Assumption is that the basic law really takes the form of a unified theory of all the particles. Now, some people call that a theory of everything. That's wrong, because the theory is quantum mechanical, and I won't go into a lot of stuff about quantum mechanics and what it's like and so on. And you've heard a lot of wrong things about it anyway. There are even movies about it with a lot of wrong stuff. But the main thing here is that it predicts probabilities. Now, sometimes those probabilities are near certainties, and in a lot of familiar cases they, of course, are. But other times they're not, and you have only probabilities for different outcomes. So what that means is that the history of the universe is not determined just by the fundamental law. It's the fundamental law and this incredibly long series of accidents or chance outcomes that is there in addition. And the fundamental theory doesn't include those chance outcomes. They are in addition. So it's not a theory of everything. And in fact, a huge amount of the information in the universe around us comes from those accidents and not just from the fundamental laws. Now, it's often said that getting closer and closer to the fundamental laws by examining phenomena at low energies and then higher energies and then higher energies, or short distances and then shorter distances and then still shorter distances and so on, is like peeling the skin of an onion. And we keep doing that to build more powerful machines, accelerators for particles. We look deeper and deeper into the structure of particles. And in that way, we get probably closer and closer to this fundamental law. Now, what happens is that as we do that, as we peel these skins of the onion, and we get closer and closer to the underlying law, we see that each skin has something in common with the previous one and with the next one. We write them out mathematically, and we see they use very similar mathematics. They require very similar mathematics. That is absolutely remarkable, and that is a central feature of what I'm trying to say today. Newton called it, that's Newton, by the way, that one. This one is Albert Einstein. Hi, Al. Anyway, he said, nature conformable to herself, personifying nature as a female. And so what happens is that the new phenomena, the new skins, the inner skins of the slightly smaller skins of the onion that we get to resemble the slightly larger ones. And the kind of mathematics that we had for the previous skin is almost the same as what we need for the next skin. And that's why the equations look so simple, because they use mathematics we already have. A trivial example is this. Newton found the law of gravity, which goes like 1 over the square of the distance between the things gravitating. Coulomb in France found the same law for electric charges. Here's an example of this similarity. You look at gravity, you see a certain law, and then you look at electricity, and sure enough, the same rule. It's a very simple example. There are lots of more sophisticated examples. Symmetry is very important in this discussion. You know what it means. A circle, for example, is symmetric under rotations about the center of the circle. You rotate around the center of the circle remains unchanged. You take a sphere in 3 dimensions, you rotate around the center of the sphere, and all those rotations leave the sphere alone. They are symmetries of the sphere. So we say in general that there's a symmetry under certain operations if those operations leave the phenomenon or its description unchanged. Maxwell's equations are, of course, symmetrical under rotations of all of space. Doesn't matter if we turn the whole of space around by some angle, it doesn't change the phenomenon of electricity or magnetism. There's a new notation in the 19th century that expressed this. And if you use that notation, the equations get a lot simpler. Then Einstein, with his special theory of relativity, looked at a whole set of symmetries of Maxwell's equations, which are called special relativity. And those symmetries then make the equations even shorter and even prettier, therefore. Let's look. You don't have to know what these things mean. It doesn't make any difference, but you can just look at the form. You can look at the form. You see above, at the top, a long list of equations with 3 components for the 3 directions of space, x, y, and z. Then, using vector analysis, you use rotational symmetry, and you get this next set. Then you use the symmetry of special relativity, and you get an even simpler set down here, showing that symmetry exhibits better and better. The more and more symmetry you have, the better you exhibit the simplicity and elegance of the theory. The last 2, the first equation says that electric charges and currents give rise to all the electric and magnetic fields. The second equation says that there is no magnetism other than that. The only magnetism comes from electric charges and currents. Someday we may find some slight hole in that argument, but for the moment that's the case. Now, here is a very exciting development that many people have not heard of. They should have heard of it, but it's a little tricky to explain in technical detail, so I won't do it. I'll just mention it. But Yang Junning, called by us Frank Yang, and Bob Mills put forward 50 years ago this generalization of Maxwell's equations with a new symmetry, a whole new symmetry. Mathematics very similar, but there was a whole new symmetry. They hoped that this would contribute somehow to particle physics. It didn't by itself contribute to particle physics. But then some of us generalized it further, and then it did. And it gave a very beautiful description of the strong force and of the weak force. So here we say again what we said before, that each skin of the onion shows a similarity to the adjoining skins. So the mathematics for the adjoining skins is very similar to what we need for the new one. And therefore it looks beautiful, because we already know how to write it in a lovely, concise way. So here are the themes. We believe there is a unified theory underlying all the regularities. Steps toward unification exhibit the simplicity. Symmetry exhibits the simplicity. And then there is self-similarity across the scales. In other words, from one skin of the onion to another one. Approximate self-similarity. And that accounts for this phenomenon. That will account for why beauty is a successful criterion for selecting the right theory. Here's what Newton himself said. Nature is very consonant and conformable to herself. One thing he was thinking of is something that most of us take for granted today, but in his day it wasn't taken for granted. There's the story, which is not absolutely certain to be right, but a lot of people told it, four sources told it, that when they had the plague in Cambridge and he went down to his mother's farm, because the university was closed, he saw an apple fall from a tree or on his head or something, and he realized suddenly that the force that drew the apple down to the earth could be the same as the force regulating the motions of the planets and the moon. That was a big unification for those days, although today we take it for granted. It's the same theory of gravity. So he said that this principle of nature, consonance, this principle of nature being very remote from the conceptions of philosophers, I forbore to describe it in that book, lest I should be accounted an extravagant freak. That's what we all have to watch out for. Especially at this meeting. And so prejudice my readers against all those things which are the main design of the book. Now, who today would claim that as a mere conceit of the human mind? That the force that causes the apple to fall to the ground is the same force that causes the planets and the moon to move around and so on. Everybody knows that. It's a property of gravitation. It's not something in the human mind. The human mind can, of course, appreciate it and enjoy it, use it, but it doesn't stem from the human mind. It stems from the character of gravity. And that's true of all the things we're talking about. They are properties of the fundamental law. The fundamental law is such that the different skins of the onion resemble one another, and therefore the math for one skin allows you to express beautifully and simply the phenomenon at the next skin. I say here that Newton did a lot of things that year. Gravity, the laws of motion, the calculus, white light composed of all the colors of the rainbow. And he could have written quite an essay on what I did over my summer vacation. So we don't have to assume these principles as separate metaphysical postulates. They follow from the fundamental theory. They are what we call emergent properties. You don't need something more to get something more. That's what emergence means. Life can emerge from physics and chemistry, plus a lot of accidents. The human mind can arise from neurobiology and a lot of accidents. The way the chemical bond arises from physics and certain accidents. It doesn't diminish the importance of these subjects to know that they follow from more fundamental things plus accidents. That's a general rule. And it's critically important to realize that. You don't need something more in order to get something more. People keep asking that when they read my book, The Quark and the Jaguar, and they say, isn't there something more beyond what you have there? Presumably they mean something supernatural. Anyway, there isn't. You don't need something more to explain something more. Thank you very much.
حتی نظریاتی مبنی بر این که بخوان این 4 تا نیرو رو به هم ربط بدن هم وجود داشته. حتی زمان انیشتین افرادی مثل کلوزا و کلاین معادلاتی رو به آقای انیشتین فرستادن و انیشتین حتی تعجب کرد که این بتونن معادلات نسبیت انیشتین رو توی بعد 5 بنویسن و بتونن اتحادی برقرار کنن بین نیروی گرانشی و سایر نیروها. از اونجا بحث‌های شروع شد و میدان‌های الکترومغناطیسی، میدان یانگ میلز و ادامهش تا الان که نظریات ابرریسمان و ریسمان‌ها شکل گرفته، همه به دنبال این موضوع بودن که بتونن این 4 تا نظریه رو یکسان بکنن و حداقل گفته شده اونجوری که اعلام میکنن نظریه ریسمان تونسته همچین کاری انجام بده. آقای ادوارد ویتن و پروفسور ایرانی به نام کامران وفا توی نظریه M و نظریه F تونستن همچین کاری رو انجام بدن و حالا این ادعایی بود ولی جایزه بزرگ آقای کامران وفا چند سال پیش بهشون اهدا شد توی این زمینه و کارهای خیلی خیلی بزرگی داره اتفاق میفته. آقای موری گلمن داره ادعا میکنه که شاید فیزیک و ساینس به صورت لایه‌های یک پیاز باشن که شما لایه بندی دارید توی پیازها که همه روی هم قرار گرفتن و این پیاز رو شکل دادن. شاید زیر همه این فرمول ها یک نظریه واحدی باشه، حالا به نام نظریه GUT، که همه معادلات به این دلیل دارن به یک فرم خاص دارن در میان. به این دلیل ما 1/2 mv2، 1/2 kx2، 1/2 li2، 1/2 cv2 و این فرمول ها رو داریم که اینها از یه جا دارن منشأ میگیرن. به این دلیل، حالا دلیلی بود که من تونستم به اون دانش آموز، به اون دانشجو اینجوری اعلام بکنم که شاید این فرمالیسم یکسانی که داره پیش میره دلیلش این باشه که اینا اصلا یکی هن و ما فعلا آگاهی خاصی در مورد این زمینه نداریم. امیدوارم این ویدیو کوتاه تونسته باشه شما رو به وادی علم نزدیکتر کرده باشه و علاقه‌مندتون بکنه به موضوعاتی که توی این زمینه توی کانال ما به اون بیشتر خواهیم پرداخت و پیگیر کانال ما باشید تا از این دست اطلاعات شما رو بیشتر آگاه بکنیم.